welcome to come to today's in the ICANN APEC Dynamic Engagement Forum. This session is talking about DNSSEC. Moderator is Champika. Champika, let me pass to you. Sorry, we cannot hear.
Can you hear me well?
Oh yeah, okay.
So good afternoon, everyone. And my name is Champika from ICANN, and I will be moderating this session. So in this session, the discussion is going to be on progress in DNSSEC validation. So today we have, first of all, actually, I want to thank TWNIC for inviting me and also the other rest of the panelists for this session. And so today we have a few panelists in this session. In the beginning, we have Nainwen Su. He is actually the Director of Department of Technology at TWNIC. Now, there will be, the discussion is going to be more focused on DNSSEC validations. Now, there have been some discussions even in the morning during some of the panel discussions and so on about DNSSEC in broader sense, more about DNS security, DNSSEC. But as we all know, there are, of course, number of aspects in terms of DNS security, and here with DNSSEC, our focus is all going to, pretty much going to be on DNSSEC validation. There are, of course, it's very difficult for us to talk only about validation without speaking about signing aspects as well. But we will be, in general, we'll be talking more on the deployment side, sharing some case studies and so on. But we will try to have some bit more focus on to the validation and the progress. Now, as I said, initially we have Nainwen Su from TWNIC. So he will share the DNSSEC status in Taiwan, and then he will also go into focus more on to authoritative servers and recursive servers. So as I said, the DNSSEC signing aspects, while focusing on to the authoritative servers, and then the validation aspect more on to the resolve aspect. And then he will also actually try to discuss more of the challenges that they are facing, especially in Taiwan. We also have Fan Jielin from Chunghwa Telecom. One of the important considerations, we thought it would be helpful for us to actually share some operational practical aspects, especially if one want to deploy DNSSEC validations, enable DNSSEC validations, maybe try to learn from, especially from a large network operator, a telco, so that that would be quite useful. So that is why we have Fan Xie speaking from Chunghwa Telecom. So he will go through mostly on the planning process, how they did that. So they have already validated, they have enabled validation in their resolvers, and also he will discuss more on to the how the progressive activations they have carried on throughout a certain period of time. So he'll go through that, and also some of the operational issues that they face and encounter as well, so that you can relate to your scenarios and situations, and try to see how we can improve, how we can support this discussion towards your deployment aspects. We also have Shan Pei from academic environment. He is actually from Taiwan Academic Network. So he will share, especially from academic networks perspective, from educational institutions and so on, what they are doing. And I think that would also be especially helpful if, especially if you are representing any campus networks and so on. Then we also have Yoshiro Yana from JPRS. It is also actually, Yoshiro has been quite involved with, especially especially in a lot of circles, network operator groups, and even within ICANN and so on. So it would be good to actually get some, especially some experience from Japan perspective, kind of case of Japan, and also he will go into more details of challenges and considerations that, especially from Japan's perspective. So that is the sort of presenter is going to discuss, and feel free to come up, have, if you have some clarifications, questions, and so on. We will also, after the presentations, we will have some time to have some discussion as well. If the time permits, maybe probably, and I would say we will get to the questions at a later stage. But if there are some questions, possibly, I'm not sure whether it can send through chat. Feel free to send it as well, so that we can try to take it all those questions as well. And thank you very much. And with that, I want to pass it on to Nain Wensu, our first speaker from TWNIC. Thank you.
Okay, good afternoon, everybody. This is Nain Wensu from TWNIC. Today we are talking about TWNIC DNSSEC status. Okay, before talking about DNSSEC, we will show you the TW status, and then the DNSSEC validation rate, and the authoritative and the recursive DNS server status, and some issues. Okay. Okay. The TW is the 20th CCTLD in the world, in the global CCTLD, and the TW is the 49th CCTLD that enable DNSSEC in the ROM. And the TWNIC also the first CCTLD that provide open resolver with the DOT and the DOH. Okay. Okay. Currently, all TWNIC registrar support the DNSSEC extension on EPP, and all domestic registrar provide DNSSEC capable DNS hosting service. It's very easy. Just one click, then you can enable your domain with DNSSEC. You don't. The registrar will care about the key manager and the key rollover and the long sign in. So you don't do anything. You don't have any knowledge of DNSSEC, then you can easy to enable the DNSSEC. And some registrars also provide the 10 TLS resource record. It is very easy. Just one click, and the server will go to your web server to fetch the credential and certificate credential, and calculate the checksums, and put to the TLS resource record. But only then 1% of the TW domain enable DNSSEC. Okay, you can see the number. Only 1,000 domain enable DNSSEC. You can see the edu.tw is almost 10%, but the rest is less than 5%. Okay. This slide show the TWNIC DNSSEC validation rate only 4%. This diagram show only 4% users in Taiwan that they use the DNS server that enable DNSSEC. It means most users in Taiwan use the ISP DNS server that not enable DNSSEC. We had do some tests on the DNS do some tests on DNS server that enable DNSSEC. You can Okay. You can see we have from 0% to 100%. We have 200K domain hosting in one DNS server, and from 0 to 100%, the zone by enable DNSSEC. Then we check the CPU utilization, certain load, and the virtual memory and the bandwidth. You can see the significant change is the bandwidth is about five times out. When we enable DNS, all zone enable DNS, the bandwidth is 5 times compared to the 0%. And the other that change not so many. Okay. This shows the DNSSEC enable on because DNS server. Yeah, it is the same from 0 to 100%. The significant change is the mass bandwidth is about 8 times. Okay. This is the DW DNSSEC issues. There are about 10 to 15% of DTL domain name that enable DNSSEC fail on validation. The major issue is the forget to replace or remove DNS record from restaurant. While DNS key was changed, it means key rollover or remove or disable the DNSSEC, but they do not remove the DNS record on the registry. And the second issue is the DNSSEC expire. Because the DNS, when you sign a zone, they usually is about 30 days available to do the validation. When the key is expired, your validation will fail. And some cases is the network security device block DNSSEC the traffic. For example, block TCP port or large packets. Okay, this is the current DTW DNSSEC issue. Okay, any questions?
Thank you, Nainwen. So, yeah, thank you, Nainwen, for your presentation. Now, as I said earlier, we will try to take the questions probably in the end after all the presenters have presented, so that participants can ask the question, direct the questions on to the speaker as well, so that the speaker, the appropriate speaker, can also actually take those questions. But I just want to actually, before we move on to the next speaker, I just want to ask you just a clarification on some of the statistics that you pointed out or mentioned in your slides. You did say that in Taiwan, currently the DNSSEC validation, it's something around 4% or so. We know that obviously there have been some measurements that have been carried out, especially even if you consider like APNIC Labs. Jeff has been doing this work for quite some time. So when we see the worldwide stats, we see it's something like 26% or so, whereas in Asia also it's something like 24%. So when you compare with those figures, like 4% is something a pretty low number. Do you, I mean, especially given that you are from TWNIC and you regularly engage with especially the network operators who are probably most your members as well, do you see any reason why this validation is not that high in comparison to, say, even Asia in general?
Okay. Actually, our government, NCC, they have called ISP, have a meeting with ISP to engage them to enable DNS. They tried, but NCC is not force the ISP to enable DNS because there are cost for when you enable DNS, you have some cost. For example, the bandwidth is the cost, and the DDoS issues and the memory issue. So NCC is not force ISP to enable, but they ask ISP ready, then some days ISP can enable DNS. But I know the NCC recently, they call ISP to meet again. Maybe this year, maybe they will ask ISP to enable DNS. If they ISP enable, I think in Taiwan the validation rate will be higher than 10 or 20%. Yeah.
Okay. Yeah. Thank you. So as I sort of understand what you think is that possibly some of the resolve operators, they are kind of they have some concerns on performance issues, especially the bandwidth, and also some of the security issues like DDoS. That is because the DNSSEC responses are pretty large, so they might be worried on that. And then obviously some of the performance aspect, like the memory and CPU and so on. So I mean, let us see. Actually, there are other presenters also actually trying to come up with some case studies, present the case studies now. So let's see if they have some solutions for these issues, so that even that might be useful for this discussion as well. Yeah, anyway, thanks very much for your presentation, and let us then go for our next speaker. So we have Fanjilin. He's from Chunghwa Telecom, one of the large telcos from Taiwan. Over to you.
Hello. Well, hello, everyone. My name's Ning Fangjie, or you can call me Jason. I'm from Chunghwa Telecom's China DNS team. It's really my pleasure and honor to be here to share with you some thoughts and experiences we have about DNSSEC. And this presentation is organized in chronological order. So firstly, I'm going to explain what we consider, what we prioritized during the preparation, and how we prefer to activate DNSSEC validation. And then I'm going to list what we did to avoid service unavailability and customer complaints during the system modification process and the process of turning on DNSSEC validation partially. I'll explain later. And then in the status quo section, you will see some screenshots that shows the outcome of the previous two phases. And lastly, I'm going to talk about the issues and concerns we have about DNSSEC. So having at least 3 million users and having been named as one of the National Critical Information Infrastructure, which is abbreviated CII. So we do know the importance of our DNS resolution service. So availability has always been the top priority, has always been our top priority. So being afraid that turning on DNSSEC validation might bring us overwhelming amount of server fail events and complaints. So we prefer to do it progressively. And by progressive, let me give you an example. Say, compare with all the domains in the world. edu.tw and the domains under the second level domain should count less and therefore be relatively more manageable. And we also believe that academic institutions should have better technical readiness and acceptance. So we chose edu.tw as our first target to turn on DNSSEC validation. So the question comes to how exactly do we confine or limit DNSSEC validation within the selected as a second level domain, which is edu.tw. The key lies in the key. What I'm saying. I mean, I'm referring to the trust anchor concept. So by feeding or installing edu.tw as a key, to be more precisely, it will be the KSK's public key. So by installing that key of edu.tw, we are able to shorten and start the chain of trust from the selected second level domain. And then the whole implementation went as follows. Firstly, we actually perform lookups to know more precisely that how many domains might become server fail after turning on DNSSEC validation. And thanks to TWNIC for the domain list and the notification to the schools. And when the check result became acceptable, we started to plan the rollback plan and did the deployment in batches. By batches, we mean we didn't change everything at once. We do it separately to avoid one single problematic change affect all the servers. And lastly, we closely and of course nervously monitor the situation for at least 2 weeks, and we arrange periodical lookup to make sure that everything goes as expected. And once there is any abnormal situation, we will get like SMS alert, etc. So even now, the partial DNSSEC validation is working. So if you send edu.tw related queries to our HiNet DNS, which is the number here, the IP here, you will see AD bit as in the reply from Google's answer. And AD bit stands for authenticated data, so that's a sign of the DNSSEC validation is working. But if you ask us other domains, such for example .com.tw, you will see the AD bit missing. So that's how it works now. And from ISP's point of view, the first technical issue would be availability threat. And such threat, firstly, might come from DDoS. And in the DNSSEC scenario, amplification attack is its impact is greatly increased. So we really care about it. And the other source of the threat is believed to be the increased technical complexity. So even now, like expired or missing RRSIG or inconsistent DS record are still often seen. So, and even though I've been told to focus on the technical issue, but I can't help sharing some practical ones, which is cost, like Mr. Shi just said. By cost, we mean because we believe that DNSSEC validation should cost more resources, computing resources. So more and better servers should be needed. At least that's how we justify our budget to our bosses. And the other cost source would be the maintenance efforts, because more higher possibility that the domain might become server fail. So that takes more efforts in troubleshooting, explaining, and even monitoring. So that's what we think for now. And even we have the progressive method, like a progressive activation method, like we just talk about. We still concern the scalability. By scalability, I mean when the target becomes like .com.tw, the number of domains would still be too big to be manageable, which means that might bring still an overwhelming amount of server fail complaints and events. So that's an issue from the higher level domain selection. And when we select a relatively low level of domain, like a specific company's domain, and that would be another scalability issue because we have to install its key into the resolver. So the result is kind of the same because there will gonna be too many install version of keys that is really hard to manage, especially we are not getting any notification or something because it's a special way of implementation. But we did we did find some reference of the method in ISC's Find DNSSEC guide, which is I list a reference here. I forgot to mention just the bottom right. It's a document that talks about the method too. So yeah, that's pretty much all I have for now. Thank you.
Yeah, thank you, Jason, for that presentation that you, especially now you went through your sort of, from Chunga Telecom perspective, how you planned and what sort of process that you carried out, especially, in terms of or before enabling the DNSSEC validation. Yeah, just like, before again, we go into the next presentation, just want to clarify that, I mean, how long have you been, when you enable DNSSEC validation, how many years ago, for example? And also just want to know whether, especially have you, after you enable DNSSEC validation, have you encountered any, especially from your customers, your network's perspective, have you encountered any, lesser number of security incidents that, probably are in your network or even any different, in any different situation, or what sort of thing have you observed?
Okay, thank you for your question. We did, our preparation lasted at least half year, probably more, almost a year, because we perform all the perform lookups as many as possible, and then keep tracking the whole situation because we're really worried about that, especially the complaints part. So, and as for what actually happened is that the method, the progressive method I mentioned has another issue, which is the key rollover. So, which means when the actual key is changed, but our install version is not, then the server fail situation is expected to occur, and it actually occurred before, and we noticed that based on our periodic lookup. So we noticed all edu.tw becomes server fail. Oh my God! So we would just change the version of key as soon as possible, and luckily, not impact was noticed. I think so. I things are cool now. Thank you.
Okay, yeah, I was actually more expecting any challenges, especially from your users' perspective, because previously before you had DNS validation, whether you used to get a lot of custom issues in relation to things like phishing or phishing attacks and things like that, and then after you validate DNSSEC, whether that sort of complaints has been reduced. So that was mostly I wanted to kind of know, but it's good to actually hear that those challenges also what you face. But just to sort of clarify, you did mention about the key rollover. So I believe that so during, say for example, during the root zone KSK rollover, during that time, had you already were you validating DNSSEC during that time? So that was like 3 years ago in 2018. So during that time, were you still validating DNSSEC?
Oh, you mean the root key rollover, right?
Yes.
No, we just focus on the we turn on the DNSSEC only for edu.tw. So it's a shortened chain of trust.
Okay. Yep. All right. And I just wanted to because in case if there are some instances that we have kind of got to know, because some resolve operators, because of the root KSK rollover, there were some tendency, they just wanted to disable the DNSSEC validation just until the root KSK rollover was done. So whether that really impacted you, just wanted to know whether that was the case. Okay, yep. Thanks for that clarifications as well, and good information to know. So let us go for our next speaker. So we have Shan Cheng from TANET, from the Taiwan Academic Network. Over to you.
Good afternoon, ladies and gentlemen. I am Shan Chen-pei from Ministry of Education. Today, I will give a brief introduction to how TANET, Taiwan Academic Network perspective to DNSSEC, this technology. First thing first, I will give a brief introduction about what is TANET. The Taiwan Academic Network is founded since 1917, and we recently 1918, sorry, there's a little bit miscount, sorry. And we recently celebrated our 30th anniversary. And now we have about 4,000 schools, research institutions, and library to connect in this network. So our users, including the students, teachers, researchers, about 4 million users to use Taiwan Academic Network. Right now, we have about 200 GPS backbone, gigabps backbone, and we have about 110 gigabps internet connection. This is Taiwan Network's main targets and main infrastructure. So the TANET in architecture is shown as the following slide, and as you can see, we have 5 core nodes in Taipei, Taichung, Tainan, and Hsinchu, and Sinica, Taipei. And we also have 13 regional network centers. It's all over the Taiwan, north, west, east, south Taiwan. Also have 13 universities. And these are our regional network centers to connect following university, college, and research institutions. And the third level is we have 22 county network centers. These county network centers is connected to high schools, elementary school, also we know as K-12 schools, is connected by 22 county network centers. And we launched our dark fiber backbone plan in 2016. After the dark fiber backbone, we promote our backbone bandwidth from about 17, 18 gigabps to 100 and now 200 gigabps. And the most special thing about Taiwan academic network is we are operated by government and schools. As you can see, the 13 regional network centers is mainly on the 13 universities all over Taiwan. So, and 22 county network centers are 22, we can say, the county government education center. They operate this node. So, we have schools, we have government units to maintain this network. Probably we are the only network operated by government and the school in Taiwan. So this is our DNS hierarchy. As you can see, the root DNS level is edu.tw. And following, we have, as you can see, the second layer will be our county or university's domain, the second level domain. And the third level will about many schools, so, about including high schools, universities, or as you can see, the college in the, some universities. And as you can see, the yellow line is the authoritative DNS service, and the blue line will be the recursive DNS queries. So, if there, we have a large difference from, as we say, the government.tw or gov.tw. That the gov.tw has a single X as I say, single recursive DNS query service. The all domain, all PC or servers in the government service network will use the single recursive service, recursive DNS service to query the domain name. And that's the difference in the Tarnet. The Tarnet we don't have a single DNS service, recursive service. So our recursive service maybe some school on their own recursive service, they use that service to query domain name from the root DNS server, and some just use the existing DNS recursive service such as Google or HiNet. As you can see, the DNSSEC in Tarnet, you can see about 9% in the subdomain in edu.tw. This is many, as we can see, the reason of the DNSSEC activation is not really high. The first thing is some of mismanagement of incorrect DNS signing is the main reason. As Chunghwa Telecom Jason has said, if you run a recursive service and some other domain activate a DNSSEC, but have some mismanagement, have some so-called key update expiration, then your user cannot approach that domain. This will cause a lot of complaint. So all management will do one thing, they will turn off the DNSSEC validation. And that's why there's lesser and lesser DNSSEC activation in this right now. Second reason, we use the main, as I can say, the Tarnet DNS recursive service is not single exit. So the main recursive service we use in Tarnet, as you can see, will be the HiNet DNS recursive service and something like Google recursive DNS service. And as you can see that a HiNet recursive DNS service is not activate validation for all of the .tw domains. There is only activate to edu.tw. But the Google is activate to all domains. So this causes a lot of confusion to users. It was talking about, I use Google DNS and I can connect. I can not connect the network, but I use HiNet, it can connect the network. So for the network administrator, it's a very, very difficult thing to solve. And third will be the lack of management ability. So to manage activation of DNSSEC is have a lot technical knowledge to do this. As you can see, the many schools in Tarnet do not have the specialized information technician. They are also, most of the time, they are just teachers or they are just students who have a lot of knowledge, but they are not professional technicians. So they cannot manage such correct DNSSEC setting. As for the Ministry of Education, we acknowledge DNSSEC should be an important problem to solve. So as you can see, our main principle to solve this problem is to activate some DNS service centralization plan. Because not every school has the ability to activate DNSSEC setting. So we use some layers. So upper layer school or upper layer node will centralize his sub-level domains and manage the DNS service for them, for this school. So school don't have to worry about the DNSSEC setting. Therefore, at this rate, the DNSSEC will be more and more rising on the percentage. And we also need some technical training and technical support enhancements. So that's all these school or network node have the ability to build activation DNSSEC service and to deal with some users' complaints to make the complaints lesser and make that the network is smoother and good. And that is our future perspective. So that's all my today's presentation. Thank you.
Thank you, Shan, for taking us through your network and especially the situation in your environment as well. I think given the interest of time, possibly we can move to the next speaker now, but then after that we can return back to some Q&A later. Also, please do note down, any questions that you have and so on, while the presenter is presenting, so that these questions can be asked in the end. So let's move to our next speaker, Yoshiro Yana from JPRS. Over to you.
Thank you. I will switch my slide. Hi, can you see my slide? Okay. So this is Yoshiro Yana from JPRS. That is the GPTLD, Japanese TLD, CCTLD. So I'm very happy to be here, but it is unfortunately I can't be in front of you. This is virtual communication, so it is very sad. Next time I'd like to visit Taipei again and see you all. So today I will explain the DNSSEC validation situation in Japan. So this is my introduction, but I skipped this because this is already on the website of this conference. So the first slide is hurdles preventing DNSSEC deployment for both sides of signing and validation. Please note that this is very my personal opinion. So this is not the common sense, but this is my opinion. As you know, the real DNSSEC deployment requires both hoils of signing side and validation side. This is very kind of chicken and egg problem. But the DNSSEC validation should deploy in advance because it is a benefit for the end users. So I explained two hurdles, both for signing side and validation side. For the signing side, there are issues regarding to the automation of signing key management and signing key registration. So there are several supporting technologies already developed in IETF and some registry registrars, but they are not building on business logic of registrant, registrar, and registry relation. This is so-called RRR relation. It is not deployed yet. And this is very interesting topic regarding to the DNSSEC deployment, but out of scope of today. And the other side, validation side, there are also two hurdles. One is automation of trust anchor update. And the second one is development of adoption policy for negative trust anchor, or so-called NTA. So negative trust anchor is used when DNSSEC validation failure happens. DNS resolver operators can turn on NTA if they find some troubles in the authoritative server side. So relative to the signing side, these hurdles in validation side are the matter of DNS full resolver operators. So the decision is just on the resolver operator side. So this is very different from the signing side. So the thing, if you or if ISPs wants to change, switch on the DNSSEC validation, it is dependent on your decision. So this is the situation of DNSSEC signing under .jp. So the total number of sign zones are very flat since 2012 to 2020. But from the last year, April of last year, the signing zone increased very highly. This is because a major DNS provider turned on the automatic DNSSEC signing services. And this graph shows the DNS validators ratio observed under JPTLD servers. As you see, the validators in Japan are increasing linearly, and it is around 20%. Okay, 20%. And under the APNIC observations, the ratio is around 15%, but recently it is around 20%, so that the observation under .jp and at the APNIC are almost the same. So the penetration of validators is around 20%, can be said as a Japanese situation. And this is the supplementary information regarding to DNS validations in Japan. So as you see, those statistics are observed for the resolver, so that it is not representing how many end users are using DNSSEC. So, and it is very hard to know how many end users are behind such full resolver DNSSEC validators. And the major users of the internet is mobile users, so that the mobile carriers are key players for the to increase the coverage of end users who uses DNSSEC. And the other aspect regarding to the DNSSEC validation is the IP protocol. Major Japanese IPv6 virtual network enablers are already providing DNSSEC, so that it is thought that validation ratio of IPv4 and IPv6 seems to be different. But I don't have, and many of my colleagues or my interface in Japan do not have such statistics, so that I think this is a good research work. So this is the last slide, and the considerations of my, also this is my personal opinion. So that most of Japanese major ISPs are still not deploying DNS validators because they fear for the failure. The exceptional major ISP is Internet Initiative Japan. And the operators in IIJ says that there are very few DNSSEC failure, so that the DNSSEC failure is not the real fear for the DNSSEC validations. But it is still not the common knowledge between the ISP operators, so that universal best practices that major ISPs can follow are very needed, especially how they adopt the policy of NTA and how, when, or what time they started to use NTA. It is a problem, and still waiting for the best practice. And this kind of knowledge should be shared among countries and regions, because this problem is the same in every country. So recently established ICANN kindness project can be a hope. I think this will be explained in the other session. And Adil from ICANN CTO is the leader of this project. And the third point is ISPs who is not deploying DNS validators are suggested to put their target timing for the next root KSK rollover, because it will be the last chance to check their configuration if they are conforming to the root KSK rollover. And the next root KSK rollover plan is not completed, but I think it will come within this 2 or 3 years, because the last root KSK rollover was 2018, so that 5 or 6 years since then is the target of next root KSK rollover. And the last consideration is medium or small ISPs might consider to provide third-party full resolver to users. That is, offer public DNS service such as Quad 101 to end users, as long as it privacy or public DNS privacy policy meets ISP policy. For example, Quad 101 or Quad 9 or Cloudflare Quad 1 explicitly explains that they do not collect end users' privacy data. So that it is, I think it is relatively safe to offer public resolver to the end users. And if they're using public resolver is a performance problem, then please consider to invite the public resolver to their location, so that the collocation is an option to offer the public DNS. Okay, this is the end of my presentation.
Yeah, thank you. Thank you very much, Yoshiro-san, for your presentation as well. I mean, there were a number of interesting points, but just want to actually quickly bring a couple of points over there before we really get into the questions. You did mention about the automation part and the importance of that. And then, of course, the challenges that you have, and then the negative trust anchors as well, and then some of the best practices related to that as well. In fact, actually, I just want to take those couple of points you did mention, especially one thing on the kindness project, especially from ICANN perspective. So kindness is a very long acronym, but just to sort of make it sort of summary for you, it is basically a framework to come up with the best practices in terms of securing DNS. So now this is an initiative, of course, which is where the community input is really needed. I mean, this case would be, for example, even in this session, some of the presenters here, they shared, their experience and also, the practices, the operational practices they do in your environments, which works best, which doesn't work better. So with all these, I think it is important for us to experience all these and then try to find what are the best practices in providing the or securing the DNS. So this is why, in fact, this whole project started. And then, because the thing is, we cannot expect every resolve operator or every network operator to be a sort of large operator. They may be having resources, but if you really consider, maybe there are lots of small networks, small operators who are operating their resolver as well. So they might want to actually look for something that they can actually apply for those best practices in their environment. So that is the kind of objective of this. So there is a community page on this project, and feel free, if there are a lot of operators who are listening to this, and if you want to even share your experiences, try to be involved in this whole project, and then we can try to build this framework so that we can all work towards securing the DNS space and applying those practices. That's the whole objective here. And also the other thing, actually, you just did mention about the root KSK rollover point of view. Yeah, the early rollover was done back in 2018, which happened successfully. And then there was a sort of proposal for public comments on having the next one. What are the things that we should be considering in terms of the next KSK rollover. So there was a proposal and a public comment period. So this report was also published last year. So that is available if you want to read that. It is available from ICANN website as well. But only thing is that currently, because of this pandemic situation, the thing hasn't really, hasn't moved up, because the thing is that it is not possible to, especially, can't do the travel to those locations as well, especially, the key management facilities and things like that. But of course, the current, the ZSK signing process, that happens. That there's no change in that. That happens. But in terms of this KSK rollover, the proposal, I mean, that's since last year that hasn't been moved, or there hasn't been updates to that. But then again, do feel free to have a look at that report as well. As I said, the public comments and then the staff report based on that. So that would also give you some more information. I think with that, it's all a good discussion that you had, especially from your perspective. So now let us go on to having some further Q&A from the audience. I believe that we are getting the questions from the room, I guess. So I'm not sure whether that's coming through chat or whether it will be directly coming through the room itself. I do not see any questions through chat though. Yeah, while waiting for any questions, I mean, if any operator here who are listening, if the whole discussion here is that how we can progress or improve enabling DNSSEC validation. I mean, of course, as I said earlier, there are two aspects to this. One is the signing aspect, and the other one is the validation aspect. And we did touch on both, but then we try to focus more on the validation. So especially if you are a operator, if you are a Resolve operator, if you're providing recursive service to your clients and so on, it is always a good practice that you enable this. And even from users' point of view, it is always good that maybe you have some discussion with your ISP, your network operator, Resolve operator, and then see whether if they can enable the DNSSEC as well. Otherwise, it will not happen. It will be just a chicken and egg problem. So this is something quite important. And then also, in comparison to the signing part, which has some complicated bits, but the validation is quite straightforward. So as long as you take those consideration that that some of the speakers who shared how they went through what sort of considerations they had, as long as you follow those, it is quite straightforward as well. And so always it's a good practice that if you can enable DNSSEC validation. anyone has any questions for any of the speakers? Okay, I don't think that we are having any questions from the audience. And also, actually, it is top of the hour now, and I believe it's time to sort of, wrap up the session, end the session. So thank you very much for all the speakers who presented today, and thank you very much for all the participants who were listening as well. And in case if you have any questions, you can separately discuss those questions and so on. Feel free to send it to the speakers, or even send it to TW-Nick, so that we can always be in touch and then try to help you out. And with that, thanks very much, and look forward to keeping in touch. Thank you.
Thank you.